Hello teachers, learners, and parents. Sir Jeff po, at your service. Alam nyo ba na meron tayong website na tinatawag na DepEd Commons? Ang DepEd Commons ay binuo upang gawing accessible ang pagtuturo at pag-aaral dito sa ating bansa gamit lamang ang inyong mga smart devices gaya ng cellphones, tablets, at computers. Dito ay maaari nating ma-access ang iba't ibang learning materials mula sa Department of Education. Meron itong mga interactive materials, electronic self-learning modules, at instructional video lessons mula sa DepEd TV na tiyak na makatutulong sa pag-aaral ng mga mag-aaral galing ka man sa public o private school. Walang problema dahil welcome ang lahat dito. Para ito sa mga guro, magulang at mga mag-aaral mula sa kinder hanggang grade 12, alternative learning system o ALS, at pati na rin ang special education. At huwag kang mag-alala dahil kahit walang load ay maaari mong ma-access ang mga learning materials. Tama! Libre ito. Ang kailangan mo lamang gawin ay i-on ang iyong data at buksan lamang ang iyong browser at i-type ang commons.deped.gov.ph. Alam na ba ng iyong mga kasamahang guro o mag-aral ang tungkol sa DepEd Commons? I-share mo na ang video na ito upang matuto rin sila kung paano gagamitin ang DepEd Commons sa mabilis at napakadaling paraan. Muli, ito po si Sir Jeff at kita-kits po tayo sa DepEd Commons. Paalam!
Magandang araw! Sir Wilbur po, at your service. Narito ang ETUlay upang gabayan ka sa inyong pag-aaral upang lubos na maunawaan ang iba't ibang paksa o subject. Ang ETUlay ay isang free online tutorial class na pinangungunahan ng DepEd Educational Technology Unit sa pamumuno ni Undersecretary Elaine Del B. Pascua. Ang programang ito ay hindi lamang para sa mga bata, kundi ito rin ay magsisilbing gabay sa mga magulang at mga guro kung paano nila ituturo o gagabayan sa bawat asignatura ang kanilang mga anak o mga estudyante. Sa kasalukuyan, ang self-learning module mula sa rehiyon ng Calabarzon at kilala sa tawag na pivot ang ginagamit sa ating ETUlay online class. Kaya ano pang hinihintay ninyo? Ihanda na ang inyong mga ballpen o lapis, papel o kwaderno at samahan kaming itulay ang pagkatuto para sa bawat batang Pilipino. Sama-sama tayong magtutulungan para malampasan ang mga hamon sa panahong ito. Halina't matuto kasama ang inyong online tutor sa oras na ito.
Magandang Lunes po sa lahat ng ating mga masugid na taga-subaybay sa ating ETUlay session. Welcome po to another ETUlay session. Tutor Lester po, at your service. We are on the third quarter of the final. We are on the third week of the final quarter of the school year. Ilang linggo na lamang po. And we will be finally crossing the bridge in what is a challenging yet fulfilling journey in our quest to learning continuity. So for this week, we will discuss propagation of light as explained by wave and particle models. Our objectives for this session are the following. Explain the wave and particle models of light. Describe reflection and refraction in terms of the wave and particle models of light. Explain propagation of light using the wave and particle models. As usual, we will be starting our tutorial session with a 5-question pretest. Simulan na po natin ang unang katanungan, mga kaitulay. He proposed that light is composed of particles that are traveling in a straight line. A. Christian Huygens. B. Louis de Broglie, C. Max Planck, D. Isaac Newton. Tamang sagot po ay D. Isaac Newton. What evidence tells that light is made up of particles traveling in a straight line? Formation of shadows when light hits obstacles, inversion of images formed on plane mirrors, C. Production of ripples when a penny is dropped to a pond, D. Scattering of light rays when they reach a smooth surface. Ang tamang sagot po ay letter A. Formation of shadows when light hits obstacles. Number 3. What is the speed of light as it propagates through space? A. 1.0 times 10 raised to the 8 meters per second. B. 2.0 times 10 raised to the 8 power meters per second. C. 3.0 times 10 raised to the 8 power meters per second. Or D. 4.0 times 10 raised to the 8 power meters per second. Samang sagot po ay letter C. Number 4. A student placed a pencil in a glass of water. Why did the pencil appear to be broken? A. Light always travels in a straight line. B. Light makes the water evaporate into the air. C. Light reflects the pencil on the water surface. D. Light bends when it passes through changing medium like air and water. Tamang sagot po ay letter D. Light bends when it passes through changing medium like air and water. Huling katanungan. Why do most leaves appear green to our sight? A. All the colors of white light are absorbed by the leaves. B. The leaves are scattered by the molecules of the green leaves. Most of the colors of incident white light are reflected from the leaves except green. D. The colors of white light are absorbed by the leaves and green waves are reflected. Tamang sagot po ay letter D. The colors of white light are absorbed by the leaves and green waves are reflected. Right? So, simulan po natin ang ating session for this afternoon. So, let us discuss the different theories about light. So, sa loob po ng napakahabang panahon ay naging isang pagtatalo po sa loob ng scientific community ng mga dalubhasa noong unang panahon upang masagot ang isang katanungan. Ang liwanag o light ba ay isang wave o alon o isang particle na maihalin tulad natin sa bigas na binubuo ng napakaraming butil na mas pino. So it was René Descartes who was the first one to study and explain the concept of refraction. So ayon kay René Descartes, light was a mechanical property of a luminous object and a transmitting medium. So how light behaves has something to do with the luminous objects and how they are transmitted in a transmitting medium. So what are these transmitting medium? So let us say these are air or water. And what are these luminous objects? So these luminous objects are the objects that produce or generate light. Descartes postulated and published a theory about the refraction of light, which states that refraction could be explained by the speed of light in different media. His theory of light was regarded as the start of the modern physical optics. So in 1675, Isaac Newton brought forward the corpuscular or the particle theory of light. So in this theory of Isaac Newton, he proposed that light are composed of particles of matter called corpuscles, which are emitted in all directions from a light source. So Newton assumed that these corpuscles travel in a straight line at high speeds. Then these corpuscles differ in size and colors and form images of objects when these corpuscles enter the eyes. So this short clip may help you understand a bit about Newton's corpuscle theory of light.
Light consists of corpuscles, which are a stream of discrete, tiny, light, and perfectly elastic particles. Every luminous source, like the sun, a lamp, or a candle, emits these corpuscles. These corpuscles travel in straight lines in all possible directions. The rate at which these corpuscles travel may differ depending on the medium in which they disperse. The vision of human beings is a consequence of these corpuscles falling on the retina of the eyes. Various colors of light are due to the difference in sizes of these corpuscles. These corpuscles could perfectly explain the concepts of reflection and refraction of light. The reflection of light, which consists of corpuscles, is just like the reflection of a perfectly elastic ball.
All right. So that short video clip perfectly explains the basic concept of the corpuscle theory of light. And now we proceed to the wave theory. So the wave theory of light was proposed by Huygens in 1678, which states that light is made up of waves. Huygens assumed the following concepts in his wave theory of light. So light coming from a source sends out waves in a medium called ether. A medium is not necessary for the propagation of waves. And light is a form of energy and has wave characteristics. And finally, a light wave has short wavelengths. So let us review the wavelength concepts that I am sure we have all learned from our junior high school. So makikita po natin dito sa slide nito. Okay, so this slide shows a photo of a wave. Okay, ito po yung wavelength denoted by the Greek letter lambda, and this wavelength is the distance between two points in the wave. So the wavelength may be longer or may be shorter. And this is a short video that explains further Huygens' wave theory.
According to Huygens, light is propagated in the form of waves through a continuous medium. Huygens assumed the existence of an invisible elastic medium called ether, which pervades all space. The disturbance from the source is propagated in the form of waves through space, and the energy is distributed equally in all directions. Huygens assumed that these waves to be longitudinal. Initially, rectilinear propagation of light could not be explained. But the difficulty was overcome when Fresnel and Young suggested that light waves are transverse. The wave theory could satisfactorily explain all the basic properties which were earlier proved by corpuscular theory, and in addition, it explains the phenomena of interference, diffraction, and polarization. According to Huygens, the velocity of light in a denser medium is less than that in a rarer medium. This is in accordance with the experimental result of Foucault. Thank you for watching. Please subscribe this channel for more videos.
Okay. So that short video clip explains that the wave theory was the only plausible way in order to explain the other phenomena of light. So from the theories brought forward by Newton and Huygens, we can say that light both behave as a wave and as a particle. So as particles, so light travel in a straight line and explains why shadows are formed. So light as a particle also explain why light is reflected off in the mirrors. Light as a particle also explains the refraction of light when it travels through different mediums. So let us say, from example, from air to water, in which light has different speeds respectively. Light also acts as a wave. Light has the ability to diffract or bend around an object. So diffraction involves a change in the direction of the waves when they pass from an opening or around obstacles along their path. Refraction happens when light waves change direction as they travel materials of different refractive indexes. So let us say from water to air or air to water. Light waves also undergo interference, which is the phenomenon that occurs when two waves meet while traveling along the same medium. So in terms of the phenomena of reflection, so light as a particle behaves as follows. So light arrives at a mirror surface as a stream of particle. So because it arrives as a stream of particles, so upon arriving at a smooth surface, so the particles bounce off in different points. So makita po natin dito, okay, itong mga pula na particle, okay, they bounce off in a different point. Okay, so when they bounce, the order of the particle are reverse. So this reversing of order results to a reversed image or a virtual image when we face a mirror. And light as a wave hitting the smooth surface of a mirror, so light bounce off or reflect, or reflect according to the arrival angle or the angle of incidence. Okay. So the front of the wave, okay, the front of the wave when it hits the surface of the mirror, okay, turns into the back of the wave. So itong likurang bahagi ng wave, so when it hits the mirror, it now becomes the front of the wave. So that phenomena also explains why an image produced in a mirror is reversed, or why the image is a virtual image. In light as a wave changes direction upon passing from the first medium to the second medium. So let us say this is the first medium is air and the second medium is water. So a small portion of each angled wavefront should impact the second medium before the rest of the front reaches the interface. Okay, so the interface, okay, this is the boundary between the second medium and the first medium. So ito na part nito, so this will travel, okay, so this will travel along the second medium while the rest of this wave is still traveling in the first medium. All right. So movement in the second medium may be slower due to the higher refractive index. So the speed of light in the second medium may be slower compared to the speed of light when it is in the first medium or the air. And because the wave fronts are traveling at different speeds, so iba ang speed niya, iba ang speed ng light waves when it travels through the air at iba ang speed ng light waves when it travels through the water. So what will happen is that the wave fronts will, the light will bend when it enters the second medium. So therefore, changing the angle of propagation. And when light exits the second medium and back into the first medium, it will follow its usual angle of propagation as it was here. So as a particle, so refracting particles of light should also change direction. So kagaya ng sa wave, light as a particle should also change direction upon passing between two different media. So let us say, for example, from air to water. So it is suggested that in this theory, that there is a force. There is a force. Merong puwersa po dito, which is which is perpendicular between the second and the first medium. So that force changes the speed of light as it enters the second medium, resulting into the bending of the light particles. Then reflection of light. So the reflection of light, especially when light reflects off a very smooth surface, results to an image being formed. So an image can only be formed in a very smooth surface, yung napaka-smooth po na surface. So forming an image is not possible in a very rough surface. So the example of a very smooth surface that can perfectly reflect light are mirrors. The images formed by the mirrors are either virtual or real, depending on the reflecting surface. So an example of this mirror is a plane mirror, yung ginagamit po natin sa bahay. So a plane mirror has a surface that is perfectly flat. So plane mirror produces a spectacular or a regular reflection. All right. Okay. So a plane mirror, as they all do, they produce a virtual image. So how do we explain po? So paano po natin maipapaliwanag ang isang virtual image? Kung nakaharap po kayo sa salamin, what does appear to be moving kapag ginalaw po natin ang ating kanang kamay? Okay, tama. So kapag nakaharap tayo sa salamin at ginalaw natin ang ating kanang kamay, what appears to be moving in your image in the mirror is it is moving its left hand. So kapag titingnan po natin ang ray diagram na makikita po natin dito sa slide, so we can see, right? So we can see that the the image of the object is formed behind the mirror. All right. So because the image is formed behind the mirror, the image distance and the object distance in the mirror are equal. So how do we measure the distance? Okay. So the distance, the distance is measured by the distance of the object to the surface of the mirror, and also the distance of the image to the surface of the mirror. Okay, we have here another example of a mirror. So this is a spherical mirror which we call as the convex mirror. So ang convex mirror, okay, it is like a plane mirror. So this produces a virtual image. But it is different to the plane mirror. Okay, it is different to the plane mirror in terms of its surface. So this convex mirror is a spherical mirror, and its reflecting surface, okay, saan po patungo ang saan po kumukurve ang reflecting surface ng convex mirror? Inward or outward? Okay, tama po. So it curves outward, and because of that, ang convex mirror po can reflect a wide angle, and it can provide a wider field of view compared to the plane mirror. So convex mirrors are used as side mirrors in vehicle. At pati sa mga convenience stores, sa groceries, nakikita po natin na may naka-install po na mga convex mirror. So how does the image compare to the object in the convex mirror as shown in the ray diagram? Okay, so ihambing po natin ang object to the image form in a convex mirror. Okay, so paano po sila nakakaiba? Okay, so the difference between the object and the image is that yes, the image form in a convex mirror is reduced or smaller than the object. And makikita po natin that the image form is located behind the convex mirror. Right, so this is another spherical mirror which we call as a concave mirror. All right, so how do you observe the image form in the concave mirror? Okay, take a look. Okay, so the image appear inverted. So the difference between this mirror to that of a convex mirror is that, okay, a concave mirror's reflective surface curves inward. Concave mirrors produces real and inverted image. Okay, bakit po naging real? Okay, this is real in the sense that kung ano po yung, let us say for example, you are facing a concave mirror. Kung igagalaw mo ang iyong right hand, okay, the same in the image, it will also appear that the image is also moving its right hand. And now, let's take a look at the diagram. So what is the orientation and the location of the image? All right. So real images, okay. So real images are formed in front of the mirror. Okay, because they are formed in front of the mirror, they are real and inverted. Pero hindi po sa lahat ng panahon, a concave mirror can produce a real image. So there will be times that a concave mirror can produce a virtual image. So a real image, no, it's not a real image, but rather a virtual image. Okay, so if the object is located between the focus and the reflecting surface, so the image will be formed behind the mirror and will be larger. So okay, apologies for the wrong use of words. This is a virtual image, but not, and this is not real. Okay. All right. So let's go. Let's proceed to the propagation of light. So we all know from our junior high school physics. So light is an electromagnetic radiation. Okay, it travels through space, and this wave is oscillating or vibrating. So this wave has both the magnetic and the electric field component. So a light has a magnetic field component and an electric field component. So this is traveling at a speed of 299,792,458 meters per second in the vacuum of space. The visible light, yung visible light na makikita natin, can be found in this electromagnetic spectrum. So this electromagnetic spectrum is composed of waves of varying frequencies. And each of these waves have their own unique wavelength. So, right. So the visible light vibrate at a different frequencies. Okay, because the visible light has different components. And these components vibrate at different frequencies. And these different frequencies can be dispersed with the use of a prism. Makikita po natin dito sa slide that okay, a white light is dispersed into different colors or different wavelengths when it is refracted through a prism. So, kada wavelength po ng white light, okay, kada wavelength po or color ng white light ay may iba't ibang wavelength. So, that's why they bend at a different angle. So, the bending at a different angle implies that each wavelength has different speed upon entering the prism. So light can also be reflected, absorbed, or transmitted. So when light falls on very smooth surfaces, like as what I have mentioned in the previous slide, it produces a specular reflection. So this specular reflection can produce image that our eyes can perceive. When it comes to how we perceive color, so paano po natin nare-recognize ang color? So this is due to the absorption and reflection of lights, certain wavelengths or colors. So for example po, if we are seeing the object as white, so it means po that all the colors are reflected. If we are seeing a black object, that means that all the wavelengths or colors of white light are absorbed by that particular object. And in this case, if we are seeing an object to be green, for example, leaves, so that means that all the other wavelengths are absorbed by the object while the green wavelength is reflected and is visible to our eye. All right. Now let me give you the summary of the things I had discussed. So the corpuscular and wave theory of light were proposed by Newton and Huygens respectively. So light travels at 3.0 times 10 raised to the 8 power meters per second in the vacuum of space. So white light is composed of light waves of different wavelength or color. And light can be reflected, refracted, and absorbed. Right, at yan po ang ating tutorial session para sa linggong ito. Sana po ay nakatulong ang ating session dito sa ETUlay para mas maintindihan niyo po ang inyong mga self-learning modules for physical science. Ilang linggo na lamang po at may tatawid na rin po natin ang school year. Ito po ang inyong tutor sa session na ito. Tutor Lester po, at your service. Kita-kita po sa susunod na linggo sa parehong oras. Para sa bata, para sa bayan. Kita-kita po next week.
Sigurado ako na marami ka na namang natutuhan sa ating ETUlay tutorial session ngayong araw. Tandaan, ito ay hindi lamang para sa ating mga mag-aaral, kundi pati rin sa ating mga minamahal na guro at mga magulang na kaagapay natin para maituloy ang pagkatuto sa kabila ng nararanasang pandemya. Patuloy ding sumubaybay sa DepEd TV para sa mga araling ginawang video episodes. Mapapanood ito mula Lunes hanggang Sabado, alas 7 ng umaga hanggang alas 7 ng gabi sa inyong mga telebisyon. Abangan bukas mula alauna ng tanghali ang iba pang aralin sa ating ETUlay free online tutorial session sa English. I-like and subscribe at manatiling nakasubaybay sa ating ETUlay tutorial session sa DepEd Edtech Unit FB page at Educational Technology Unit channel sa YouTube at sa DepEd Tayo at DepEd Philippines social media accounts. Paalam!